Could you repeat it maybe?
D D M A S. D for division,
Oh,
M for
multiplication. Oh yeah. Okay, yeah, I know.
so
Mod mass, D mass, yeah.
that was the pi was multiplying with the product of 5 square into 9. So the minus the next one is, so first you will have to multiply that. You can see the screenshot. You can
Yeah.
see that solution. That was all right, but where you are subtracting thus the digits only. So that's why that is the mistake if you are going to the final answer.
Okay.
Okay. So that is not mistake that you pi is there. Pi is already there, but if pi is there, you will have to multiply with that. So don't subtract the numbers only. First multiply, then
Okay.
subtract. So anyhow, the right choice was 9 into 5 square into pi minus 3 cube. So that was what I mean to say 9 into 25 into pi minus 27. So when you are
Okay.
multiplying 25 into 9, you are getting some number. So you are subtracting that time. So that was the little mistake. Anyhow, we are just going to continue that. So these are the minor mistakes. So that's why I am saying that you must send the outlines of your syllabus. Okay.
All
So
right.
all these things will be very much beneficial for you when you are in school and you are just going to solve these problems. So this is very helpful. Anyhow, we are just going to start the next one, next question. That is very simple. So we have done almost 50 question of this second test. So the next is, let me share the screen first, the whiteboard. So you can
Okay.
write the things over here. I'm sure that you know you are looking my, what I mean to say, screen. That is the whiteboard.
Yeah, I
Okay,
am.
so I'm just going to maximize it. Or this is now the full zoom. Okay, what we'll have to do, the question is that a circle is inscribed in a square. So let me put the square and then the circle. So let's suppose this is the square. If I can draw exactly that one. Anyhow, you can say this is a square. And one more
Okay.
is that if I'm just going to draw the circle. So this is a visual aspect of the problem, that let's suppose if I can draw the circle in this way. So let me check if it can touch the sides. So this is the circle. Now a circle is inscribed. So this red circle is inscribed inside in a square as shown to you. If x is the distance from the center of the circle to a vertex of the square. What I mean to say, let's see if I can draw the center. So that may be somewhere over here. That is the center. If I can just adjust, this is the center. So center of the circle. So if I'm joining this center to the vertex, this vertex, are you getting me?
Yeah.
Okay. So a circle is inscribed in a square if x is the distance from the center of the circle to a vertex of the square. Then what is the length of the radius of the circle in term of x? What I mean to say, that if this length is what I just look at this, if this is
Okay.
x, x is just like that. So x is the, what I mean to say that x is the length of this one. Okay, this line.
Okay.
So you will have to find the length of the radius. What I mean to say that if the radius can be drawn over here, just like that, that this is the radius.
Okay.
So you will have to find the length of this radius. Okay. So what should be that? Just make use of paper and pen. And if you are getting the answer, it's absolutely right. Otherwise, I am here. It's a question number 51.
Okay. So what values were given?
You will have to find the value of the radius of the circle. What I mean to say, what is the length of the radius of the circle in term of x? In term of x,
So X would be that line, and then okay. Let's see. So if that's X, could we just? Oh wait, no. Hmm. I'm not sure how to like
okay,
go at
okay,
this
okay,
question.
okay, okay. Let me explain it. So first,
Sure.
draw horizontal line segment. I have drawn that for you. This
Right.
line segment, which is also the radius of the circle, is it?
Yeah.
Yes. From the center of the circle to the right side of the square. So it's a right side of the square. This creates 45, 45. What I mean to say, can you see the angles? This is now 45, and here we have also 45 degree.
All right.
So we have a right angle triangle now.
Okay.
Okay. So what you will have to do now, I think it's very simple. So in this way, this creates 45, 45 and 90 degree. Am I right?
Yeah.
You can see the angles in the triangle. Recall that the ratio of the side is, this type of the angle is under root 2 of that length of the hypotenuse. To find the length of the
Yeah.
sides, and hence the radius divide the hypotenuse. So what you will get the answer, that is what I mean to say. If this is the x, so you can, if you are using the Pythagoras theorem, so x is equal to, and one thing more is, if these angles are equal, what I mean to say, this is of the 45 degree, am I right? This is
Yeah.
also of the 45 degree. So this side must be equal to this side, am I right?
Yep.
So if both are, what I mean to say, a and a, then x square is equal to a square. Let's suppose this is a plus a square also, because these two sides are equal. So in this way, we will get x square is equal to 2a square. And if we are taking the square root on both sides, we will get x is equal to under root 2a. And we are looking for a, the radius, which is also the radius. So this will be x over under root 2. Are you getting this? This will be the
Yeah.
radius a. That is also the radius. So what we
Okay.
can say, this was all about the calculation that is just in front of you, radius.
Right.
So this is the radius, what I mean to say. Radius is what in term of x?
Square root. So X over square root.
Is this right? I'm saying 2a square, because we are using the hypotenuse theorem, Pythagoras theorem. The square of the hypotenuse
Isn't
is equal
there?
to,
Wait.
Yes.
Isn't there like a way? I remember, I think from geometry class where like there's a certain like size for all these angles, or like since like there's 30, 90, 30, 60, 90 triangles, and like there's like a way to memorize it, right?
Okay.
Since it's like a 45, 45, 90. Or am I wrong about that?
Okay. Absolutely right what you are saying. But here we are also using the geometrical aspects of this triangle. That is, if the sides, two sides of a right angle triangles are equal, their angles are equal, then the corresponding sides are also equal. So here you can say we have a right angle triangle. Let me explain this one.
Right.
Let's suppose if we have a triangle, look at this, that if this is a triangle, so what we can say, let's suppose I will have to redraw this just to make
Sure.
it appropriate in the sense that this side and this side is equal. Or in other
All right.
words, if this angle and this angle is equal, whatsoever the angle is, so the side opposite to the angle, equal angle, this is a side opposite and this is a side opposite. They must be
Yeah.
equal. This is A, this is B. And if these two angles are equal, then their corresponding sides, opposite sides are also equal. Then A is equal to B. Are you getting this?
Yeah.
Now, in the previous diagram, if I can show you, that is, let me spotlight this one. So this was all that the geometrical diagram which was given as per the question, as per the statement. We have a sphere and we have inscribed a circle. Then we are connecting the center of the circle to the vertex of the sphere, this line. So the measurement of this line is x. We will have to find the radius of this circle in terms of x. So this line is going throughout the vertex. So if we are just going to draw a line, so this line is also touching the circle as well as the sphere. Am I right?
Yeah.
And this is also the radius of the circle. We are looking for this measurement, the radius. Now we have seen that this is a 90-degree because the each and every angle of sphere is of 90-degree. Am I right?
Yeah. Yep.
So if we are just connecting the vertex, so this will be half of 90, that is 45-degree. This angle is 45-degree.
All
And
right.
this angle is 90-degree because these two lines are blue and this line red is mutually perpendicular. So this will be 90-degree. Now if we have 45 this, 90 this, so this will automatically be 45. Am I right? Are you getting
Right.
this? So the
Yeah.
45 and the 45. So as per that rule, the equal angles, their corresponding sides, opposite sides must be equal. So that's why this side of the triangle and this side of the triangle must be equal. What I mean to say, from this length to this one and from this to this. So we are interested to calculate this. So now we have a right angle triangle. By the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the square of other two sides. So that's why I have written this one. So x square, that is the, I mean to say, hypotenuse of this triangle, right angle triangle. And this is the one side, this one, and the other is also equal to a. So that's why a square. Are you getting this?
Yeah. Okay.
So x square as it is. So we'll have to add this to a square, having taking the square root on the both sides. We'll get x on the left hand side and on the right. This will be square root of 2a. So that must be a x over under root 2. Am I right? Are you getting this?
Right. Yeah.
So this is absolutely the right answer. So this was all about that. So what we are making use of, what you are saying, that is absolutely right, but you will have to utilize those, the ratios of the triangles having the equal sides, they must have the equal angles, and the vice versa. If the equal angles, the sides, the corresponding opposite side must be also equal. So here we have a straightforward geometry. So is there any doubt?
No. Okay. I understand now.
Okay, you got this one. So this was a simple. Okay, we are just going to the next question. So that is the whiteboard. Now the question is very simple. Simple in the sense that we have the two matrices are there. If I can write these. One is 4A and then 3. This is the first row, minus 1, the third element in the first row. The second row is 2A and 1 and 5. So this is the first matrix. And then the second one is just like that. That is 2 and 7. And in the second row, 4 and 3. I'm sure that you are also writing 1,
Yeah.
5, and this is the close. And the product, so there is a sign of multiplication. We can say we are multiplying these two matrices. So what the answer is, if we are multiplying, so we will get 35 and 88 over here and 13 in the second row, first element, and 42. So this is all about that. What value of A satisfy the matrix equation above? So we are looking for the value of A.
Okay. Let me just finish writing real quick. Then I'll.
Okay. Can you solve this? Any idea?
I'm not sure. I don't think we've actually been over this yet. So
Actually, to multiply two matrices together, multiply the value in each row of the first matrix by those in each column of the second matrix and add the products together. There is no use to multiply everything out as the equations only ask for the value of A in the first row. So use the value in the upper left of the matrix on the right of the equation. To determine what value of A would result is 35. So we will have to equate only the one thing, 35. The equation becomes, if you are multiplying this, so this 4A will be multiplied by, this 4A will multiply with 2 first element in the first row and first column. This is the column. What I mean to say, this is the row 1 and this is column 1. So first to first. So we will have to multiply this. What we will get, that is, what I mean to say, that is when you are multiplying this. So what should be the answer? You can multiply also this one. So 4 into what? Can you multiply this? 4A into 2, then plus 3 into 4, then plus minus 1 into 1. So
so
this will be
4
multiplied with this
A.
one,
Okay.
and the last one will multiply by last entry. So we will get 8A plus 12 minus 1 first entry, so that must be equal to 35. We are not interested in the other quantities. So here we'll get 8a plus 11, 8a plus 11
Okay.
plus 11 is equal to 35. So what should be the next one?
8 plus 11 is equal to 35. And
Uh,
then
then
next one is
subtract
3
11 from
times
both
4.
sides. Subtract 11 from both sides. So
Okay.
8a is equal to 24. And a is equal to what? A is equal to 3. Am I right?
Yeah.
So this is all about the multiplication of matrices.
Yeah. I was like, not like, I don't know about this yet. So I think we're
Okay.
going to probably do it this
You
semester.
never study about the matrices.
No, I don't remember learning this or like how
Okay.
to solve these.
Addition of the matrices, the multiplication of the matrices. But this question is right over there in the model papers of ACT. So I have a book which you have
Well,
sent
that's
me.
because I haven't finished the second semester of junior
Okay,
year.
okay,
We're
okay, no
learning
problem, no
advanced
problem, no
algebra.
problem. That's why I'm asking the outlines of your
Yeah.
syllabus. So I must touch all those questions first, where you
I
have.
thought, oh, right. I was gonna send it to you, but then my phone
Okay,
broke.
okay.
Okay, I'll find a way to send it.
At your own time, you can send. So I will touch all those questions, although I am skipping a lot of questions which are at the higher level. So this is right about the ACT Premium Preparation 2020. And we are just going to finish the second test out of these 8 model tests. So this was a question number 51 right over there. So that's why this is a question 52. So that's why I'm touching this. But if I having all those outlines, so this will definitely I will touch all those questions first. Anyhow, okay, now you have got the idea. What I mean to say, when the multiplication of the matrices is concerned, so you will have to multiply the first row to the first column. First row of the first matrix, each and every corresponding entries will be multiplied with each other to the first column of the second matrix. As we have, this is the first row and
Right.
this is the first column. So corresponding
Okay.
entries, first will multiplied with first, second
First.
will multiplied with second, third will multiply with third. So we
Okay.
have this one. And when the matrices are equal, so their corresponding entries, we will get the first element. So first element in the result is 35. So we are not multiplying the other entries. So in this way, you can get the answer. Anyhow, it's not a very difficult one.
Yeah,
Next
it's
is,
not hard to understand.
okay. Anyhow, the next one is very simple. We have talked about that. So there was a full, what we can say, slideshow for that. So once again, we have that problem. So first of all, I will have to draw the figure if I can draw that. So let me draw with these lines. So if the line is just like that, one line is the
Okay.
second, what I mean to say, the second line is also just like that. From here, if you, I can draw that. So this is going over here. Oh, yes. The third one is just joining these two at the bottom. What I mean to say. So, okay, this one is the triangle. What I mean to say. And one more thing is, if you are just going to draw one more line that is dividing this triangle right from here, from the top to the, so this line is just dividing this, and perpendicularly. This angle is of 90 degree. And these two angles, if I can draw these two angles, this is the angle and this is also the angle. Both are equal and their measurement is 40 degree. What I mean to say, if
Okay.
I can just put the 40 over here, 40 degree, 40 each. So this is of the 40 and this is also of the 40 degree, 40 degree, 40, 40. Now this is all about the diagram. And one more thing is that is also given, that is this line is 6 feet, 6 feet. So 6 feet line, this one is the length of this line.
The
So
bottom?
we are looking to find the height. What I mean to say, that we are looking to find the height of this line, or this line. These are both the equals. So we are looking for that. So what is this height? What I mean to say. Now the what we can say, the height, this one. Okay. So once again, I am just going to read the full statement. This was all about the geometry of the problem. The cross-sectional view of a tent, you can consider as a tent, is shown to you if the tent is 6 feet wide at its
Okay.
base, that is the line 6 feet at the base, then which of the following expression could be used to calculate the height of the tent in feet? So
Okay.
what you will have to do, that is that you are looking for the height. So you are not going to find the height, but you will have to get the relation. So this time I must say the 5 option. One is 3 over tangent 80. The second is 3 into tangent of 40 degree. The third one is 3 over tangent of 40 degree. The J option, what I mean to say, the second last, fourth option is 6 into tangent of 40 degree. The K is 3 into tangent of 80 degree. So this is all about that. So what we'll have to do, that exactly we are just going to say that this height, if I can write this one. Okay, let me draw this one. So this is of 3 feet. This is also of
Okay.
3 feet. So we are looking for this height because this and this are equal. Now we have a
Yeah.
triangle and this is of the 90 degree angle. So here you will have to recall S, O, H and C, A, H, and last one T, O, A. Soka Toa. Okay. So you will
Okay.
have to select any suitable, either this one, or this one for this triangle. For this triangle, you can say for this one,
We're
you
gonna
can,
use
this is of 90
Toa.
degree. This
Yeah.
is you are looking for, this is 3, and this angle is of 40 degree. So you can draw just
Right.
like that. So what should be the relation? So we are looking for the height. This is the height.
Right.
This is 3. This is 90 degree. This is of 40 degree. So how can you find the height? 40 degree.
We could use the, let's see.
This or this? Which one?
So we need to find the adjacent to 90 degrees. So that is, what is that like? So isn't that so?
Sine Opposite to
Oh,
hypotenuse, cosine adjacent to hypotenuse, tangent opposite to adjacent. Soka toa.
well, to find I think it's, well, I'm just gonna use what like the because I think what I think is conflicting to like the options, because I think it's koa, right? Or tangent. That it says 3/tangent, but I'm thinking that it's what do you call it?
3 over
What's it?
tangent of
Cosine?
40. So from
Yeah.
this triangle, you are looking for that. So what you will have to say that if you are just applying this tangent of 40 degree, so this will be tangent of 40 degree is equal to the opposite. Opposite is 3. Adjacent, if you are using this one, adjacent side is h, and you are looking for h.
Right.
H is equal to 3 over tangent of 40. Am I right?
Right.
So this
Yeah.
is the right option. Okay,
Okay.
you got that. So you will have to be quick when you are talking about these type of the ratios, because we have gone through this lesson very deeply or
Yeah.
comprehensively, and I have also sent all those slides. So just look
Right.
at those slides and you will come to know very quickly. Anyhow, this was the, so we are just going to do one more problem is, that is, which of the following sets has the lowest standard deviation? So standard deviation, I think you might not have, we are just skipping this. For all integers, integer value of a and b such that a is greater than b, b is less than 0, which of the following must also be an integer? So we are just skipping this. Now one more is a circular running. Okay. So the next is, be careful. I am just reading this one. A circular running track is being built in a fenced in athletic field, 100 feet wide and 150 feet long. If a border of 10 feet is needed between the outside edge of the track and the fence, what is the radius of the largest track that can be built? So once again, let me speak this problem in detail.
Yeah.
And that is very simple if you can draw the geometry of this one. So this is all about that. Sketch the rectangular 100 feet by 150. What I mean to say, if you can sketch the rectangular field or fencing just like that. So it's a, what we can say, 100 by 150, 150 by hundreds. So this is 150
Oh, it's what? Okay.
and 100.
All right.
The 10 feet border within the field creates a new smaller rectangle, 80 feet by 130. Am I right?
Right.
30 feet inside. So that can be drawn just like that. 30 feet. This is the border. So this will have 130. So dimension will be 130 into 80. 130 into 80. Am I right?
Okay.
Are you getting this?
Right. Yeah, the inside. Okay.
Okay, inside. And it's at, what we can say, 10 feet. So 10 mean 20 twice from
Right.
every side. So that's, it will become 20 because 10 feet border within the field. The largest circle that can fit in this rectangular has a diameter of 80 feet. 10 into 10 into 80. So it has a radius of 40 feet. So what should be, once again, we are looking for the answer. So that is that if I can give you the, what I mean to say, if you are just, so we are looking for that. If after drawing this diagram, so if a border of 10 feet is needed between the outside edge of the track and the fence, what is the radius of the largest track that can be built? Because we are looking for the circular track over here. So what should be the border of that? So we will have to convert this into circle. So can you solve this? Just try it.
Yeah,
Everything is plain. The largest circle
right.
that can fit in this rectangle has a diameter of 80 feet.
And it's talking about the just to be clear, it's talking about the yellow triangle, right? Or rectangle.
Yes, you will have to
Okay.
transform this whole diagram into a circular shape, because at
All
the
right.
a circular running track is being built in a fenced in athletic field, 100 feet wide and 150 feet long. If a border of 10 feet is needed between the outside edge of the track and the fence, what is the radius of the largest track that can be? So this is all the geometry which what we can say is that 100 feet by 150 feet, the red line, the 10 feet border within the field areas are new, that is the yellow one, smaller rectangle,
Right.
80 by 130. The largest circle that can fit in this rectangle has a diameter of 80 feet. 80 feet largest, because what we can say, this is the inside 80. Now we have this one. If you're just putting the circle over here, look at this. So if we are just going to draw the circle, the largest circle can be drawn from in this way. This one, just like that. Look at this.
Yeah.
So we have just seen that this is length, that is exactly what I can say. If we are just going to draw the diameter is just like that.
Yeah.
So
That's
diameter,
40.
not more than what? 80.
80. Yeah. The radius is
Am I
40.
right? So
Yeah.
we are looking for the, once again, I am repeating the problem. If a border is, so what is the radius of the largest track that can be made?
40.
So radius, this is the largest possible, because this is the pavement, this is the
Yeah.
border area.
Yeah.
So
That's the
that
fenced off
can be drawn
area.
over here. So if
Right.
we have the diameter, so what should be the radius?
40.
40, exactly. This time you are very quick. What I mean to say,
Yeah.
that
Yeah.
you will have to be, because this is the center and this will be the radius. So this track can be made over here. So what they are looking for, that what is the radius of the largest track that can be built. So this is all about what we can say, that if we can understand, if we are, that's why I have told you, then whenever you are facing the word problem, so you will have to visualize, you will
Yeah.
have to give the meanings to the mathematical forms. So you will have to convert that. So this is all about the
Right.
geometrical problem. So red line is just talking about the fencing, and 10 feet. 10 feet mean that from 10 from here, 10 from here. So total 20.
Yeah.
So 10 from here, 10 from here. So 10 feet is needed between the outside edge. So outside edge and the track of the fence. So that will become 20. So once again, you will have to keep this 10 is turning to 20. So we will have to draw the new rectangle that is of the yellow color. Then in this is the possible area where we can build the circular track, athletic track. So it must have the largest one. So largest is just within this rectangle, can have the diameter of its width. that is now shrinking to 80 feet. So that's why if the diameter is 80, so we can draw the largest circular athletic track that is having the radius of 40 feet. Okay, I'm sure that the answer is
Yeah.
40 feet. Absolutely right
Yeah.
answer. Okay, the next is once again there is a solid geometrical problem. So I'm sure that you will draw before me. Okay.
Yeah.
If a
Okay.
sphere is cut by two different planes, dividing it into sections, how many sections it is possible to end up with? So you will have to visualize what I mean to say. The sphere, imagine cutting an orange, or it's a good way to describe this one. So this is, let's suppose if I can draw the orange, what I mean to say, this one. Okay, look at this.
All right.
Just visualize this one.
Sure.
Imagine cutting an orange. The first slice, one plane, cuts it into two pieces.
All
If
right.
you hold those two pieces together and make another slice, the second plane, you can cut both of these pieces, thereby
Yeah.
four sections. So your answer, how many sections this is you are looking for. So what should be that? So possible
What? It's
answers.
infinite, right? I'm pretty sure there's not a certain like amount where you can stop, right?
So let's see uh, if you are cutting this one with a one plane. So this is a plane, you can say your
Right.
knife or big,
Yeah.
you can say. So this one. And if you are just holding this and one more plane, that
Okay.
will be a cutter, that is just this one. Now, how many sections is it possible to end up with? The choices are two only, two or four only, three or four only. So
You could it could be okay, so if you make another
two, three
one,
or four only. We
so
have
I say it'd be three or four only.
three or four. Please explain your answer. Why you are saying this?
So you could draw a straight line right next to it too, right? Or does it have to cut in between?
Oh,
Because if it
yes.
doesn't have to cut in between, then what do you call it? Then it can be three because you could just draw a straight line next to the other straight line.
Hmm.
And then the
So
other one where it cuts in between, you could just make one of those.
yeah, yeah. Okay. So for one more option is look at this. So this is absolutely we have four. But if
Right.
somebody is just like insisting that he has his own orange, what I mean to say, somebody is just like that. He has
Right.
it's his own orange.
Okay.
And what he is going to do, look at this. He said, okay, you are saying that twice, I will have to cut it twice. Let it, okay, he will cut just like that. Okay, he will cut just like that. Okay, this is the one, and this is the second.
Yeah.
So how many sections now?
That's three sections.
Three section. Okay, so either you have four, if somebody is just be that justice should be done, that four equal, and if somebody is interested to divide it into three, so he can cut with the two planes, two knives, just like one cut, the second cut, and we have only 3. Other options, 2 only. So 2 only is not possible. 2 or 4 only. 4 is possible, but 2 is eliminated from 3 only. So 3, but some one can just do in this way. 3 and 4. 2, 3 and 4. So out of these 5 options, 3 and 4 are the feasible options. Okay? Are you getting this?
Okay.
So this one, just like that. So one thing is, one more question we can solve in
Sure.
this time. That is, for all real value of A and B, the equation. So I should write straight away the equation. That is that A and minus B in mod absolute. So this is equal to 5. Can be interpreted as the positive difference of A and B is 5. So positive difference A and B. What is the positive difference between the two solutions for A? So you will have to find the solutions.
Sure.
Okay.
So,
Positive difference of two solutions.
okay, so it is
Positive difference being that when you subtract A minus B, you get plus 5 or minus 5 as per this.
right.
So we have the two values with both the sign. That also what the absolute value indicates. So this is the meaning of absolute, either minus 5 or plus 5. Solve for A
Yeah.
in both cases. A minus B is equal to 5 and A is equal to B plus 5 and A minus B is equal to minus 5. So A is equal to B minus 5. Now subtract these two values, B plus A and minus B minus A. So 10. So that's why your answer must be 10. Are you getting this? How can you solve this? I have explained each and everything that in this way you can put a line just like that. So we have the two values, either A minus B is equal to positive 5 or either
Right.
A minus B is equal to minus 5. So these are the two. Once again, I'm reading. For
Right.
all values, the positive difference of A, B is 5. What is the positive difference between the two solutions? So if you are looking for first solution, A is equal to B plus 5. Am I right? And
Right.
from here, A is equal to minus B minus 5.
Right.
So the difference is, look at the difference of these two solutions. This is the first solution for A. This is the second solution for A. And the difference between these two solutions, this will give you what? 10. This will
Yeah.
give you 10 only. Am I right?
Yep.
How? But how? Question is, you can ask how. Let me explain how. A is equal to B plus 5 and A, once again A is the second solution is minus B and that was, what was that? Minus B minus 5. Minus B
Right.
minus 5.
5.
So we are subtracting, changing the
Okay.
sign. This will become
Yeah.
positive. And this
Yeah.
is also become positive. So this will go on over here and this will be 2B and this will be 10. So in this way, we can say that 10 is the positive solution because we are not interested A and B. So
Yeah.
difference of these two solutions, that will be, because here A minus B, this, so 5 plus 5 we are looking for the, and answers are also given in terms of what I mean to say digits. So 10 is the right option. I'm sure that you have got this one. Okay, so this was the end of the second test. What I mean to say, we have a few questions. We will definitely solve those because you are not very much touchy with all those topics. So please send the outlines of your syllabus, that what you have done and what you are going to do in the next sessions in your class. So
Okay.
okay, so it's a time to say Allah Hafiz. Okay,
Allah Hafiz.
Allah
Okay.
Hafiz. So